Hi guys, greetings of the day. Welcome to my YouTube channel for learning a subject called Fluid Power Engineering for 5th semester and Fluid Power Systems for 7th semester as per VTU syllabus. If you haven't subscribed to my channel yet, kindly subscribe. Also click on bell icon to receive the latest lectures as and when it is uploaded in my YouTube channel. Now let's start the session number 46, which is based on the logic gates in pneumatic applications. Now, based on this, we have two conditions. We'll understand the condition one, that is control of extension of a double acting cylinder. The circuit uses OR gate, an AND gate, and a memory device for its control, and figure shows the circuit. And how does it work? Let us understand. The signal is fed to the OR gate either through port A or B by depressing it. The output of OR gate, that is nothing but the shuttle valve, is fed into an AND gate by depressing the button C. The AND gate is a 3 by 2 direction control valve. The output of AND gate is fed into the memory device, a 4 by 2 direction control valve, which remember to keep pressure on the black end of the cylinder during extension. Any one of the valve V1 or V2 is actuated by depressing the knob, and signal is sent to valve V3, which is a shuttle valve, that is nothing but the OR gate. The shuttle valve send the signal to valve V4, which acts as an AND gate, which gets actuated and signals to valve V5, and then valve V5 gets actuated and extend the cylinder, and also remember to keep the pressure on the blank end of the cylinder during extension. At the end of extension, the inhibit valve, a 3 by 2 valve, is actuated by operating the lever with the help of a piston rod of an extending cylinder, and an actuator of inhibit valve retracts the cylinder. This is how it will work in condition 1. Let us understand one more condition, that is called a sequential control of two double acting cylinder using pneumatic valves. Pneumatic circuit for sequential control of two double acting cylinders using logic gates is shown in this figure. And how does it function? To start with the cylinder C1 and C2 in the retracted position, the start button of valve V1 depressed momentarily, which actuates the valve V1. This allows the pilot signals to strike the valve V2. The pilot signal actuates the valve V2, which directs the compressed air from P through A and to the cylinder C1 and extends it. At the end of extension of the cylinder C1, the lever L2 of V4 is operated by the piston rod, which actuates the valve V4. This allows the pilot signal to strike off the valve V5. The pilot signal actuates the valve V5 and allows compressed air to flow through 1 and 2 of V5, that is valve 5, and extends the cylinder to C2. At the end of extension of cylinder C2, the piston rod of C2 operates the lever L3 of valve V6, which in turn actuates the valve V6. The valve V6 upon actuation allows the pilot signal to strike the valve V2 and actuates the same. This retracts the cylinder C1, and at the end of retraction of cylinder C1, the piston rod of C1 operates the lever L1 and actuates the valve V3, which in turn actuates the valve V5 and retracts the cylinder C2. Thus, the completion of one cycle of extension and retraction of double acting cylinder is in sequence. Now let us understand the concept called as pressure dependent controls. The sequence valve developed in pneumatics for the purpose of controlling certain operations and factors by means of pressure. Owing to particular design, features and the absence of an exhaust, it can be in practice be used only in conjunction with the direction control valve. The symbolic representation is as shown in figure A, since it is complicated to draw a sequence valve in the same way shown, and therefore the form of representation is shown in the figure B. Then use the pressure controlled reversal of a double acting cylinder. We are going to discuss based on two concepts. One is called as using limit switches for end position checking. The sequence valve SV should be set to such a pressure that a switching point is just less than the prevailing working pressure. By depressing the start button of the valve V1 is actuated and directs the pilot to valve V3. The pilot signal actuates the valve V3, which in turn extends the cylinder 1A. When the cylinder is completely extended, it operates the limit switch L5 of a DC valve V2. In addition, the cylinder being stationary after extension, the pressure builds up and operates the sequence valve, sends the pilot signal to the right of the memory device through valve V2. The pilot valve actuates the memory device and retracts the cylinder. Thus, the cycle is going to be operated, which shows in the circuit diagram in the previous slide what we had discussed. Then the pressure controlled reversal without limit switch, that is mechanical checking, we are going to discuss now. In this type, the reversal also occurs if the cylinder is stopped in any intermediate position, that is where the maximum pressure can build up. Now the figure shows the circuit diagram for the pressure control reversal without limit switch. This type of control should be used only where the demands with respect to certainty of operations are not too great, or where there are no possibility of using limit switches, or alternatively where a reversal is required when specific opposing force arises. And how does it function? The start button of the valve V1 depressed, which actuates the valve V1. This results in signals from 1 to 2 actuating the valve V2. High pressure air from the compressor enter the head end of the cylinder C through the ports 1 and 2 of valve V2, and the extension of the cylinder C takes place. At the end of extension, pressure is built up on the head end side of the cylinder, which actuates the sequence valve. The actuated sequence valve sends a signal to the valve V2, which brings the valve V2 to the normal position. The normal position of the valve sends the high pressure air from compressor to the rod end of the cylinder and retracts the cylinder. Here, actuation and retraction of the cylinder is completely with the valves only. And then we are going to discuss the next concept, that is called as time dependent control circuits, which is based on two concepts. First, we will discuss the reversal of double acting cylinders, that is nothing but checking of end of extension using a limit switch. Time delay valves can be used for controlling the double acting cylinder using a limit switch that check for the extension of the cylinder. Upon working, to start with, the button of V2 is depressed, which allows the signal to flow from ports P to A to actuate the valve V1. In the actuated position of valve V1, high pressure air from the compressor enters the head end of the cylinder and extends. At the end of extension, the piston rod activates the limit switch L1 of the valve V3, which actuates the valve V3. The actuated valve V3 allows the high pressure to enter the time delay reservoir. Depending on the deviation of time set, the time delay valve operates the 3 by 2 DC valves, that is direction control valve of the time delay valve, which allow high pressure air from ports P and A to return the valve V1 to the normal position. If the normal position of the V1 and the ports P and B as well as A and R are connected, resulting in retraction of the cylinder. Thus, the time delay can be made between the extension and the commencement of the retraction using a time delay valve. And the figure shows the circuit diagram for time dependent reversal of double acting cylinder with a check for end of extension using a limit switch. The time commences after the extension of cylinder 1A has taken place and retraction commences at the end of time set on the throttle of time delay valve, which is called as time delay. Then we have one more concept that is called as time dependent retraction without limit switch. This circuit has the advantage of working without the limit switch but at the expense of operation reliability. In case the time element is pressurized as soon as the valve V1 is actuated, that is, at the beginning of the extension stroke, that is, the pure dwell period of the piston rod in its end of the piston stroke, extension of the piston stroke position is dependent on the duration of the extension stroke, which can as well known vary tremendously. In addition to this, the pressure buildup on the rod end side of the piston is not constant. Depending on the load, which is an additional source of error in the circuit, and the circuit shows for the time dependent reaction without the switch. So by this, I would like to conclude the session. Thanks for your patience listening to the session. If you have any sort of doubts, feel free to use the comment section for further discussion. I will answer all your questions related to the topics covered in the session. Don't forget to like, share and subscribe. Have a great day. Signing off, Vijay Tavartan.